Good afternoon, Professor. I am Raisa Akhtar Zaman, a PhD student in mechanical engineering, and the title for the project I have chosen is Accurate Cell Classification in Neuronal Fluorescence Images, a Data Mining Approach. So on the right side, you can see a picture of a fluorescence image that has been captured for the neuron cells. And in the image, we can see that there are different shapes of neuron cells. Now, the shape of the neuron cell tells a lot about how the neuron cells are, the structural integrity of the neuron cells, and the physiological state of it. So classifying the cells into circular and acircular is a key feature that we're looking for, and that's what have been done during the project. A predictive model have been built for this purpose. I used 10 images and I extracted a total of around 1300 cell features for the project. So over here, we can see that after the cell segmentation, it does depict an accurate number of cell count, therefore meaning that the cells have been accurately segmented. And then we can see that the shape of the cells are kept after the cell segmentation. For each of the segments, I have extracted the features and manually compiled them into one file. And in that file, I have given scoring for each of the cells as 1 for a circular shape and 0 for circular shape. So I identified key input features like ellipsoidality, radius, area, perimeter, circularity for each of the segments. And I used a machine learning algorithm, for example, random forest. I also used gradient boost to rank feature importance. So according to this recursive feature elimination, I found that circularity is most important over here, and this is what we expected because this is what we're looking for. But for the project, I tried to use something that is more difficult to predict. For example, if I can relate ellipsoidality with radius. We can see that ellipsoidality and perimeter are at a very low importance, and even lower is radius and area. So I wanted to target one from each of these low importance and then see if we can do a very good machine learning model and then do hyperparameter tuning to make it perform even better. So I used different machine learning models like KNN, SMV, neuron network to compare the different accuracy levels and different mean square error levels for each. Before doing that, I tried to visualize the kind of data I'm working with. So over here, I can see that the frequency and classification is not quite balanced. The frequency of 0 data and 10 data are quite very different. The ideal scenario would be if I had similar number of 0 data and 1 data, but for the scope of this project, I used only 10 images, and from there I could only extract this amount, and this can lead to some ambiguity in the prediction model. Also, if we plot the ellipsoidality and radius, this is another reason why I chose these two. We can see that there is a distinct boundary line between these two classifications, and uh, a very good predictive model can be used if we know this kind of trend between the plot of the two datas for which we're willing to predict the classification. So this is an example of the k nearest neighbor model where I used Greek search CV with five-fold cross validation. The search space includes number of neighbors, weight function, and distance metrics. Total fits 12 candidate combinations, 60 models were evaluated, and the best configuration was found to be distance metric to be Manhattan, number of neighbors to be 7, weighing to be distance based. So this is a table that I made after running each of the model, and hyper tuning of each of the model have been done, and the best hyper tuning models have been listed, and the corresponding errors, R square values, accuracies have been listed for comparison. To better visualize this data, I have done a scatter plot, and over here we can see that the KNN model, the root mean square value and the mean absolute errors are quite high for this model, but we can also see that the R square value is quite low for this model. So we can, from here, we can conclude that only looking at RMSE or MAE or R square value is not an optimal way of doing it. We have to assess all of these parameters to conclude to the best model. Also, I have done the accuracy scoring for all the models that I have tested. And from here, we can see that the scalar vector metrics and logistic regression model were good according to accuracy. But if we are looking at the F1 score, the best option is the KNN model or the gradient boost. And the F1 score can be counted quite similar for each of these cases, and the precision of the KNN model is quite low. So we can conclude that the SMV model is a good option if we are evaluating the models that I have listed here. This is all from me for this project. I have learned a lot from this project thanks to professor, and I hope I can use these models and further enhance the output of these models and utilize it in my research scope. Thank you. That's all from me today.